Hello, everybody. Welcome to today's Microsoft Reactor live stream event. Thank you all so much for joining us from wherever you are based in the world. Welcome, good morning, good afternoon, good evening from wherever you are joining us. My name is Hadeel Shiber, and I'm very excited to present to you today's session. This is the first session of my Data Science for Beginners series, which I am beginning. This is basically going to be a very beginner friendly, very kind of interactive, fun way for people who are interested maybe in diving deep into the data science field, or maybe people who want to kind of don't know how to get started into data science. So this actually kind of series is for you. So stay tuned and follow along for an exciting beginner friendly session. So today's session, we're going to start by kind of talking about defining data science, talking all about the data types, the different formats of data that we have, kind of talking through like the data science life cycle, kind of just introducing you to those foundational concepts so you can kind of build a framework for your knowledge and be able to kind of get started by taking the right steps into the data science journey. That being said, we are going to get started. So before we start kind of digging deep into the content of today's session, I just wanted to kindly remind you that our event today is part of our Microsoft Reactors Code of Conduct, meaning, we want to have a welcoming and respectful atmosphere. We want to always be understanding of our different opinions and, thoughts. And, let's make it an interactive session, a fun session. We're all here to learn. So let's, empower each other as much as we possibly can. Before we begin, I would like to ask you a question, and I would love for the audience, online audience who are joining us, please let us know in the comments where you are joining us from. We have it's a worldwide kind of broad event. We're live streaming right now. I am based in Dubai, United Arab Emirates. So I would like to know if there are any fellow, Dubaians based or UAE residents based here. Just let me know where you're joining us from in the chat box. That being said, I will kindly just briefly introduce myself to the community for the people who have not seen me before. So my name is Hadeel Shiber, and I am a regional cloud advocate and data analytics engineer at Microsoft Reactor Middle East and Africa. So part of what I do as a regional cloud advocate is basically I kind of love to share knowledge in what in tech topics. So basically my areas of expertise lie around the data science field, the data analytics field, artificial intelligence, machine learning, as well as kind of exploring other kind of tech topics that are, always evolving and that are, always growing, because we live in a kind of in a world where all these new tech topics, and we have the cloud, and we have Microsoft Azure, and we have all these new kind of technologies and tools that are absolutely awesome, and, that are actually huge advancements in the era that we're living in today. So I love to explore these topics alongside with you, kind of share my knowledge and my expertise, as well as kind of learn with you alongside and explore new topics like the Internet of Things, like maybe mixed reality, the metaverse, and for example, many other topics in Microsoft Azure services, cognitive services, so many more. Power BI, Power Apps, low code, no code. So you'll see a lot of those kind of sessions that I love to kind of host and do. That being said, again, please let us know in the comments, where you're joining us from. And that being said, let's start. So today's topic is all about data science. So we are going to kind of dive deep into the foundational concepts of data science. And before we begin, I just wanted to kindly, let the audience know that this session is kind of going to be a bit theoretical. So I'm going to kind of tell you the most important foundational concepts that you kind of need to know, and so you can build your knowledge before taking the right steps to kind of building a model if you want, or maybe working on a hands-on project, or if you have like a data set in hand and you want to kind of analyze your data. I will kind of teach you the three steps before it, kind of explain to absolute beginners here who have no idea where to start. So we're going to kind of talk about, data science concepts, defining data science, talk about the importance of this field, why it's blooming, and kind of maybe like types of data science, the types of data that we have, and obviously taking you through like the data science process, because this is kind of the most important thing. So it's going to be a very fun interactive session, so I would love to kind of hear from you. So now we live in a world where, it's 2022. We live in a data driven world. We are living in a world where we have big data, we have data science, we have data analytics, we have artificial intelligence, machine learning, Internet of Things, the metaverse, and we have all these new upcoming technologies that are actually coming up, and they're actually shaping the future. They are actually shaping what we are today. So obviously, the power of all these new technologies and tools are actually revolutionizing the world. you know this is where the data science insights come into play. So using data science, we are like every single industry or arena there is out there that you could literally think of can depend on data science in order to kind of drive the decision making process, or to drive the insights, or to drive maybe changes, or make even improvements in those industries. So data science is actually a field that is actually growing every day. You have all these cool technologies and tools, Microsoft tools, platforms, and such, that are actually help you kind of take the right steps towards, being, like taking the right steps towards being, let's say, a data scientist or a data analyst, in that matter. So obviously, this data science field is absolutely blooming, and this is what we are going to be talking about today. So let's begin with the most basic. Let's talk about what data is. So basically, we as human beings, in our natural kind of habitat, we always actually naturally operate with data by kind of, in going through our daily lives. So for example, when you count the money you have in your wallet, or maybe if you write letters to your friends, or maybe you are sending a message, text messages to your family, those are all actually, you are actually kind of using data or generating data. So as human beings, we naturally operate with data on a daily basis without even realizing it. So obviously, we live in a world where we are constantly surrounded by data. And data, what is data? Data is facts, numbers, observations. It's basically anything that is used to record information. But this information does not really make sense until you actually take it and, process it, and be able to make insights, and grab insights, and be able to make, better decision making towards it. So, for example, the text that you're reading here on the screen today, this is data. The list of phone numbers you have on your phone, for example, is data. So anything basically that you kind of have around you on your smartphone, using videos, images, searches, and such, web clicks, sensors, you have data. So data is literally everywhere. Now, obviously, with the creation of computers, and then, we have, we live in a world where obviously we can't live without the internet. We have the Internet of Things, where everything around it is connected to the internet. Data has become even more critical with the creation of computers, because the primary role of computers was to literally perform computations. But now they actually need the data to operate on it, so they are able to, make those computations. Therefore, it's very important for us, as humans and such, to kind of understand where this data is stored, how we can process this data, and how computers store and process that data. So, as I said, we live in a data-driven world. We have the Internet of Things, where everything around us is connected to the internet. With the emergence of the internet, which now obviously I can say that, we can't live without. The role of computers, obviously, in handling the data devices has actually increased. So now we kind of depend on, we use computers more now to kind of process the data that we have for us. So, let's say you have a raw data, you will not understand or make use of that data until you actually kind of take it, process it, and be able to kind of, grab your insights from it. So, for example, let's say you are writing an email to a friend, or maybe you're adding a number to your phone, or such, or maybe like searching for something on Google. What you're actually doing as a human is you're actually generating, creating, storing, transmitting, and manipulating data. So it's actually a whole process that you do. You might think that, oh, it's just, a simple email that I'm writing and then just send it away and it's good to go. No, but actually behind the scenes you have that data, which actually, has goes through like that kind of stage. So this is where we are at today. So if you don't know, we are, as humans, we actually generate around 2.5 quintillion bytes of data every single day. And by 2.5 quintillion, I think that's a term that not many of us are familiar with. I myself was shocked. Quintillion is, we have 18 zeros. So can you only imagine the amount of data that we generate? And everything around us can be data, everything that and we're surrounded by. It could be from the social media websites and clicks that we use, from Instagram to Twitter to maybe Google searches to YouTube to Netflix. We have the business transactions from financials and such. Location-based data. For example, we have, Google Maps. We all now depend on Google Maps to kind of, if we're driving to a new location, for example, and you have Google Maps will obviously, because Google Maps uses real-time data, so live data, it will actually kind of show you what is the best route to go, or if you have, for example, a blocked road and you should go on another route, or if you, if there's a roundabout ahead of you. But if you don't have Google Maps, you can still kind of live without it. You can depend on the signs on the streets. However, you can only see the signs on of the streets for maybe around like 200 to 400 meters away. But you wouldn't know, like, if you come close, if there's like traffic, if there's construction, congestion, there's a blocked road, if there's an accident, if there's anything. So now, with the use of real time data, where we live in a world which is absolutely incredible to me, we can know, by using, for example, Google Maps and such, that we are able to make better decisions based on the data that we have. We can also obviously generate data from sensors, from digital photos, from videos, from consumer behaviors, like from e-commerce and online and source transactions as well. So that being said, there's actually data everywhere around us. Where, like, if you take a minute and think about it, and just take a minute to kind of look around you, you will realize the amount of data that you are actually generating. So now we can say, since we live in a data-driven world, we have data that is publicly available to around us, from the internet, from surveys, from web scraping and such. And obviously, we can say that the database technology is actually booming. And now we have very, huge cloud-based and mobile applications that are actually also being advanced in this huge world. So let's say, let's take this scenario. Let's kind of have a fun think about this kind of with me. So let's say you are an owner of a store, and for example, let's say an e-commerce store, and you would like to know how you can, for example, increase the revenue of your products, for example, in the next few months. So how can you actually know? You would like to predict, you would like to foresee, you would like to kind of draw some kind of insights, just to kind of know what areas you can focus on to increase the revenue. You want to see the strengths, you want to see the weaknesses, and kind of build on that. All of that means that all of that is nothing without data. So as long as you have data, you are able to kind of you are able to predict, you're able to do some forecasting, you're able to kind of make some customer satisfaction if you want, market differentiation. You are able to kind of draw some prevention rules and regulations, give a great user experience. This is all based on data. So for example, if you are if you can think of kind of some scenarios or questions that can come to mind. And for example, as we can see here, for example, you can think, how can I price a particular product? So you work in a store and you have a product that is new and you don't know what the price range is. However, you need to make sure that, when you're competing with other markets, like, the range is the same. But how do you price that product, without, like, for example, seeing what other competitors are doing, without knowing what the market is? That is dependent on data. So, for example, how can a customer, or like what will customers buy more in the winter season, for example? What should I stock more of? What is the price point for example, customer retention for subscriptions? What can you recommend online customers to buy after buying, product A, B, and C? So all these kind of questions, you will not be able to answer it without having data. So that being said, if you have data, you will know the answers to these questions. Now that we've talked about data, let's dig deeper into data science. So, as Wikipedia says, data science is defined as a scientific field that actually uses scientific approaches and methods in order to help, extract raw knowledge and insights, and apply actionable insights from data across a broad range of application domains. And the best way to put this definition into easier words is that data science is how I like to call it, the science of data. So you're basically literally, we defined what data is, we know what science is. So you are literally using scientific methods and techniques, in data analytics and data science. So you kind of basically, data analytics kind of steps. You are using those scientific methods in order to extract invaluable information that will help you kind of make better decisions towards your organization, your business, your product, or such. So data science is, if we can think of it, is basically you're making sense of data, because data is nothing until you actually look at it and start making sense of it. It will just look like normal information to you. But it's very good to know that the more data we have, the more analysis we have. And this is actually something that, in data science is very important. It's very important that, when you start working on your project, is to keep in mind that the more data I have, the more valuable information I will have, which means the better kind of analysis, and the better results it will kind of maybe give me. So, that being said, data science is used for analysis, prediction, learning, and prevention, and it is utilized in a wide variety of industries. So, what industries really depend on data science? We have any industry that you could literally think of. For example, healthcare, the retail industry, the finance and banking. For example, you have logistics and transportation. For example, you have travel, you have education. So marketing, anything you could literally think of, whatever sector it is, you can use data science, and data science can be applied to those sectors in order to help improve, and help them make better decisions. And data science actually involves two types of data sources: structured or unstructured data, and we have another one which is called semi-structured data, and these are actually going to be covered in the following slides. So just to kind of summarize everything that we're saying, data science, since it's the science of data, you kind of depend obviously on scientific methods and techniques to extract valuable insights. So you can expect that data science, uses kind of probability, statistics, some kind of mathematical computations, because you, by the end of it, want to build a model. If you have an objective to kind of, increase the revenue in the next few months, you kind of you kind of need to go through, collect the revenue data, for example, collect the product data, collect historical data, and based on that, you have to do the analysis. You have to build a good model based on what you're looking for, and by the end of that, you kind of have to test and see the results based on the objective that you have. So we can say that, this is very important. This is one of the most important kind of fields that is actually booming today. And obviously, in data science, it's very important to know that, it studies the way how the data can be gathered, how it's collected, actually, how it is stored, and how it is operated upon using computers by going through the data science lifecycle, which we will kind of talk about and touch upon today. And as I said, since data science kind of uses mathematical techniques and, algorithms and such to draw insights from data, this is actually why it is very important, because before that we were not able to kind of be able to predict. We were not able to forecast, to foresee, to kind of help us kind of see what the next step is for us, or for our business, or for our products, or for our customers, and such. So it helps you, data science kind of helps you answer all the questions you kind of have in mind. So we can say that it is, considered to be a separate paradigm of science in four kind of ways. So in an empirical way, we rely mostly on observations and results of experiments. So data science is all about kind of experimenting in a way. So obviously you will kind of do many observations and predictions and such, and based on those experiments, you will rely on those observations. Theoretical, meaning that you will extract and use scientific methods and techniques in order to, gather the insights and, go through the process. Computational is basically when you use obviously mathematical or computational experiments. This is also known as, the new principles that we have, algorithms and such. And it could be, data science could be data driven, meaning this is where you actually use the data analytics kind of part of it, where we kind of discover relationships between attributes, kind of discover the hidden patterns we have in the data, and kind of even highlight the most important features that we have. So, since we talked all about data science, there are actually other relational fields that are very important and are, you have to know when you kind of get into this field. We have databases, and databases are basically like where the data is stored and how to store the data. So we all have the database, we have the cloud, and this is where this kind of allows for faster processing, especially when you have structured or unstructured data, or you have big data. Databases are where the data is stored. Big data, just like its name is, as I said, we live in a world where we generate 2.5 quintillion bytes of data every day. And I believe this number will only continue to grow over the years. So you have these large quantities of data. And how do you even store them or even process such a huge amount of big data? So with big data, there is kind of ways and tools and techniques that are able to store that huge amount of data, and also even arrange it in like a distributed manner, and process it efficiently so we can make use of it. The third term that is kind of our field that is also very important and very close to data science, and it actually depends, data science actually depends on it heavily, is machine learning. So data science and machine learning go hand on hand together. So when it comes to data science, you are building a model. And to build a model, you will use machine learning algorithms or machine learning techniques in order to predict the desired outcome that you're looking for. So when you want to develop models from data, this is what we call machine learning. And we will touch upon machine learning in the upcoming slides today as well, since it's very important. AI, or artificial intelligence. So this is an area of machine learning, and it relies on data. So basically, we use AI to mimic human behavior. You are literally training a machine or a computer, by building high complexity models that kind of mimic exactly, or copy exactly what us as humans can do. So you kind of use AI methods to turn unstructured data into structured data. So, and the last kind of maybe relational field that is very important to know is data visualization. So you have raw data, and this raw data will not make any sense except if you kind of process that data. You will have raw data into valuable insights and information. Once you have your insights and information, when it goes through the analytics process, this is where you use data visualizations to present, beautiful visualizations like charts or graphs or, plots, in order to kind of draw conclusions of, all the data analytics process that you've done. So this is actually one of the most important things that we use in as data scientists or data analytics, and you should always know how to use the right kind of visualization type and when to use it. So there are actually many techniques and many ways and many different types of visualizations that we actually use, from charts to scatter plots to histograms to timelines to bubble graphs and so many more. So you might ask me, Hadeel, how do I know which visualization to use by the end of my project? So I actually inserted kind of summary that will show you which visualizations you can use, and it will make kind of your life a bit easier when wanting to take the decision to choose the right visualization. And it's important to know that when you visualize the information, that your visualizations are clear, straight to the point, understood. You don't want to kind of break on your data analytics process and all that just to have it be in complex tables and such. No, you want it to be as simple, as readable as possible, because by the end of your data analytics process, it's very important for you to communicate your results to your stakeholders, to the business owners, to your clients, or even kind of to the organization that you're working in. So it's very important that the results or the visualizations are clear, straight to the point, and very readable. Now that we've talked all about that, let's talk about the three formats of data that we always hear about. We have structured data, semi-structured data, and unstructured data. So structured data is data that has or follows a structure, just like its name. Semi-structured is data that is between structured and unstructured, so it follows some kind of structured schema, but not fully. And unstructured data is data that has no format or no structure at all. So, for example, structured data could be a list of, like, let's say, people with their phone numbers. So it could be, an Excel sheet which has phone numbers listed, very clear, very straight to the point. Probably when it's structured, meaning, it's an Excel sheet, for example, it's, separated into rows and columns. So it's very clear, straight to the point data that, is absolutely, in the right format. Semi-structured data, the best example I can give you for this one is emails. So emails don't follow a specific structure, but they do have some structure or some format to it. And unstructured data is data that does not have or follow any structure at all. And this is actually the hardest type of data, because obviously us as data scientists, a fun fact is we deal with 80% of what we deal with is of the data that we get is unstructured. So we can't actually analyze our data and apply, machine learning algorithms and build it if our data is unstructured, because that will be just very messy. So we need to kind of follow, what we call, or change unstructured data to structured data. And for example, the best example that I can give you for unstructured data is, for example, video files or images. Or texts and such. So those obviously they don't have a specific structure to them, and they need to be converted from unstructured to structured. The way we can do that is going to be explained in the next few slides. So here's just as a brief overview of how it could look like. So on the right, you have the structured data, rows and columns, very clear to the point. We have the fields of each and all that. Semi-structured data, the one in the middle. So as we can see, you have kind of the fields of it, but it's not following a specific schema in a way. And the unstructured data, as you can see, everything is just messy. You have some parentheses here. It's not really clear and straight to the point. So it needs to be structured in order to kind of be processed. Now, you might ask me, okay, Hadeel, that's cool and all. So I want to work on a project, but what are the best possible sources of data and where can I get my data from? Now, the list is actually endless, and it's actually impossible to list all the data sources that you can find. However, some typical places I put down here in this chart, just some typical examples where you can get data so you can have an idea. So if you're looking for structured data, the Internet of Things, it's your best bet. So Internet of Things means that everything around us is connected to the Internet. So for example, e-business, e-travel, e-finance, e-commerce, emails, and anything that is basically connected to the Internet. Internet of Things is one of the best ways or sources of data that you can get. You have surveys. So obviously you can ask people to fill in some surveys for you and such, and this is actually considered as data. So for example, to rate the store that you have, or for example, you can ask them like questionnaires such as, what products would you like to see? So this is actually data or analysis of behavior. Unstructured data. For unstructured data, some sources could be text, images, videos, or even web server logs or APIs and such. And semi-structured data, as I said, the data could be from emails, from tweets. You tweet on Twitter, or spreadsheets as well that might not have like a fixed structure to it. I made your life easier, and I actually listed down here for you some resources where you can find data sets. So let's say you are a beginner in this kind of field, and you would like to start by after let's say taking, the online courses that you want to learn about data science, after kind of learning the foundational concept, you want to actually start by building your own project. So I've listed down for you here some links that are very useful for you to find data sets. And most of them are open source data sets. So they're free to the public, and they literally have, a lot of kind of industries, or a lot of like data sets from wherever you could possibly think of. So, for example, we have Kaggle. Kaggle, I believe most of us know. This is actually one of the best resources for you for open data sets. So if you search on Kaggle, for example, transportation data set, you want to, work on a transportation problem or something, you want to predict, for example, the number of cars or the traffic at a certain time, you will need transportation data. So you can go on Kaggle and search, or on any of the other links. And on Microsoft Docs, actually, we have an Azure open data set also, which you can search, and we have some different topics. So definitely check these links out if you are a beginner and you don't know where to get some free open source data sets. Now let's dig into the actual, kind of the part of this whole, the highlight of this kind of, data science journey. So it's very important to mention that, in a data science, a typical data science workflow is uh, has does follow a specific structure, but it is not actually fixed wherever you are. So it could actually differ from one organization to another, from one project to another, from one business user to another. It really depends on your objective, the steps that you want to go through, and such. However, a typical workflow could look like something like this. So first of all, just very briefly, you will kind of business problem understanding. You will kind of need to define your objective, define what the problem is, clearly identify it, and make sure that goal is highlighted. Because based on that first step, if you are not clear with your goal, you will not be able to proceed. So let's say your goal is to increase the revenue. Your goal is to, for example, launch a new product in the market. Your goal is to open a new branch in, for example, another country of your store. So based on what your goal is, you will be able to kind of follow the next steps, that come after it. After you kind of define your goal, you will collect your data. And by collecting your data, you are obviously web scraping, you are looking maybe through internet search, through maybe doing some surveys. It really depends on your problem. But it's very important to know that with the data collection part, it's very important to collect the data that's related to your problem, obviously. So if you are launching, for example, if you want to launch a new product in the market, you kind of have to look at the data that is, surrounded by that product, what it is, and like, for example, the type of product it is, how many users use it, what is it used for, anything, any kind of, anything that surrounds that. After that, most of the time, the data that we have is messy, so you need to kind of clean your data and process it. And then it goes through a step called exploratory data analytics, where you basically, as a data scientist, you kind of look at the data set and you start giving your own data, kind of give your own kind of inputs. So you look at the data and you start extracting any kind of hidden patterns, any insights that you might useful, trying to find any relationships between attributes, and even highlighting the most important features. Then you will start by building your actual model and then evaluating that model. So you'll build machine learning algorithms and build that model. And based on that, you will communicate the result of the model based on your objective, and then actually deploy it to production. So these are the kind of steps that they go through. Now, here I'm going to kind of talk about the five stages, the very five important stages that are, let's say, a necessity in a way, for any kind of project that you are, looking at. So with data acquisition, this is the way where you collect the data storage. This is where you can store the data, how you store data. It makes sense, where you store the data. Is it in a database? Is it in the cloud? Where is it stored? Data processing. This is kind of, one of the most exciting parts in the data journey. And this is basically where you convert that raw data into actual insights that can be used then into and presented into beautiful visualizations. and such. Then we have the data visualizations, as I explained before. This is where you kind of, understand and dig deeper into the different visualization techniques that you have in order to kind of, look at your beautiful raw data presented into graphs and charts and such. And then you will train a predictive model. So because the goal of any data science project, or basically the goal of data science itself, is to help you make decisions based on data, you kind of want to understand the techniques of the machine, of how to build a machine learning algorithm, or how to build or how to use machine learning algorithms in order to build a predictive model. And so I'm going to touch upon that in the next few slides. So let's kind of start by defining data. So it's very important to know that, obviously, data, raw data is just raw data. It will not make sense until you actually analyze it. So basically, the structure of a data set can be organized into or classified into three types. You have structured data, semi-structured data, and unstructured data, which we have already touched upon. And it's very important to know that the source will kind of vary between these three categories. Then we have what we call quantitative and qualitative data. So you might ask me, Hadeel, what is quantitative and what is qualitative, and what makes each different? Quantitative is just like its name, quantities. So you are basically observing anything that is numerical within a data set. So you have a data set that has, like, for example, the temperature of the temperature of a room or something, or you have a country's population and such. So these are in numbers, or maybe a person's height and weight. Qualitative data is data that is not numerical. So it could be something like video comments on YouTube. It could be, for example, your favorite color and such. So data that is not related to numbers. Then we go deeper into structured data. The reason why we're touching a lot upon structured, semi-structured, and unstructured data is because when you go through the data science process, you will know that, as a data scientist, or as someone who is learning data science, you will come across data sets that are structured. You will come across data sets that are semi-structured and data sets that are unstructured. So you should be able to know the difference between each of them and how you can deal with each one of them, in a perfect kind of scenario. So structured data is, as I mentioned, it is data that is structured, has a specific format, rows, columns, and all that. So you can obviously imagine a spreadsheet of customers, and their phone numbers and their email address, and, for example, their house address. So you have a spreadsheet and it's organized and everything is filled and it is perfect. So examples of structured data can be also bank statements, relational databases, spreadsheets, and phone numbers. When it comes to unstructured data, obviously it does not follow a typical structure or format, and that being said, obviously this takes a lot of time from us, as data scientists, to kind of convert it into structured data. So unstructured data types could be, as I said before, videos, images, text messages, and such. And semi-structured data is kind of a combination of both. So it does not follow a fixed format, or it does not have a kind of a fixed set of rules. And for example, the best example for semi-structured is emails. So you have subject, you have the body, and you have, for example, there is a set of recipients that you want to send and such. And these are like the way that you follow, but the actual content does not follow a specific structure. Now let's talk about the sources of data. So as I mentioned before, there are possibly huge and millions of sources of data that we have available to us. And it's very important for us to know where the data was generated, where does it actually live, and where does it actually come from. So we have two types of kind of sources. So you have primary data and you have secondary data. Primary data is the data that we generate. And the secondary data comes from a source that was collected for general use. So, for example, to understand this better, we have a group of scientists that collect, for example, observations in a rainforest, and those would be considered as primary. However, if they decide to share it with other scientists and get their insights and such, this will be considered as secondary. Now, some sources of data where you can get data and such is databases. You have files like audios, images, spreadsheets like Excel. You have internet sources, of course, where databases as well can be found, and you have APIs or application programming interfaces, which are, it allows programmers to kind of create ways to share their data with external users and such. And this also includes web scraping, so you extract data from kind of web pages on the internet and such. So these are some sources of data that we have. Now, let's dig deeper into the stages of data science. So, as mentioned before, I kind of briefly touched upon that, but now let's go a bit into more detail, because as a beginner, or as as a data scientist, or as someone who wants to learn and get into this field, it's important to kind of know the process or the typical workflow or framework that you need to follow. Now, as I mentioned before, that there is no typical or specific exact format that you should follow for your project in data science. However, this is what an example it could look like, and these are like the steps that are very important. So you have a starting point. You will kind of define your objective and have a plan. After that, you will collect your data based on the objective you have, and then you will check your data, check if you have any errors in it, and this will go through the data cleaning and data processing step. After you clean your data, it's ready to go. It will go through the actual data analytics, which is the actual exciting part of the data science life cycle. This is where we kind of do all the computational stuff and such. And then we will go through the data modeling. This is where you actually build a predictive model. So you will select feature, you will select a model, and then you will evaluate the results. These are three steps that we will touch upon. And then lastly, you will deploy it into production and kind of check and such how it goes. Now let's kind of talk about each one in more details, just to give you, because under each one there's like under each step there's a lot of details that you need to know and important steps that you cannot miss out on. So I'm going to kind of tell you and show you what are the most important steps that fall under each of these let's say features or under these stages. Data acquisition. So after you've defined your objective, it is very important, when you identify the problem that you're trying to solve, when it's clear to you, you want to, as I said, predict, for example, the forecast of the weather, for example, next week. If you want to predict the number of sales that you will be getting in the next few months, whatever it is, after you kind of identify the problem that you're trying to solve, you as a data scientist, you must assess some questions. For example, you need to know before collecting your data what type of data is actually available. So once you search, is it public? Do I have enough data? Do I not have it? Is it available to me? Is it not? And then you can ask, for example, what might be required and currently is not collected. So what might you need but you cannot find? Is it available in other units of the company? For example, how much data is needed? The volume of the data. Do I need more data, or is my data enough? And touching on this point, I just wanted to say that the more data, the better. How to access the data. So this talks about kind of the accessibility of the data, and is the data private or not. This talks about the data privacy and kind of the ethics of data. Is it legally okay to use the data? Now, these steps for accessibility, data privacy, and for example, the ethics of data are actually highlighted in a GitHub kind of curriculum that I will share with you by the end of this. And actually, this data science kind of series is actually featured based on the GitHub curriculum. It has all the kind of details that will show you, if you want to kind of dig deeper, for example, or have a deep dive into, about, let's say you are interested in knowing about the privacy of data and what you need to know and the foundational concepts and all that. This GitHub repo exactly highlights all those details for you. It highlights a lot of important topics. For example, the importance of probability and statistics. It shows you some kind of different visualizations that you have. For example, it shows you how to kind of work with Python. So make sure to stay tuned. At the end, I will share that link with you. So now we are in the data acquisition step. After that, we need to know in that step that sometimes, there are some issues that might happen in this step. So sometimes, you've identified your objective. However, you cannot find that data. So there is a problem that this data may not actually exist. And sometimes also some sources of data may be public or may be private. It really depends. And not all sources of data may be suitable for processing. So in data processing, there are specific formats obviously that can be used. So not all formats or sources might be suitable, and this is actually an issue. And also, as I said, most of the time, uh, actually 80% of the time, us as data scientists, when we work with data or when we find a data set, like 80% of the time, it is actually messy. And by messy, I mean it's incomplete, it's dirty, it needs to go through the data cleaning stage. And this is why data cleaning is very essential, because obviously some pieces of data may come from different sources. You might have incomplete values, you might have values that don't even make sense, you might have some missing fields and such. So we kind of need to treat that before it goes to the processing stage, so we are able to build a model. For example, when it comes to data acquisition or gathering the data or collecting the data, let's give an example of an online customer experience. So when you go through an online customer experience, you may require collecting like lots of data. For example, I put some examples here for you. For example, the website clicks that you've done, the conversions. For example, you have the exits and time to purchase, the add to cart rates and such. So these are all valuable information or valuable kind of data that we can collect regarding online customer experience that can help us make decisions regarding that that industry or such. So we've collected our data. What is the next step? The next step is we will look at our data and we need to kind of go through the data cleaning process. What that means is garbage in, garbage out. This is actually a very famous terminology kind of way that we use a lot, and you will hear a lot in data science, specifically in the data cleaning stage. And this basically means, if you have bad data or like messy data, and by bad or messy data, I mean data that, has a data set that has typos or has missing values, incomplete values, impossible data combinations that don't make sense. It has outliers or out of range values or null values. So anything that doesn't really make sense or does not contribute to the data set or is so out of like the data set, this leads to bad data. And a bad data means a bad model, which means a very bad result. So therefore, it's very important to treat and the data right. And we have to really check for any kind of errors that we have. And this is why we have the data cleaning step. Fun fact, 80 to 90% of data scientists actually, agree that this step, data cleaning, is actually the most time consuming because, you kind of need to go through the data sets that we have in hand before making sure it's processed, to make sure it's clean, it's perfect, and it's ready to go. So this is a very important one. Why is it important to go through the data cleaning kind of process? As I said, bad data leads to a bad model, which leads to a bad result. Therefore, it's very important to kind of make sure that the data we have is properly organized, properly structured, makes sense, makes it easily searchable for users, and even if you want to share it with others, it's very easy to use and very easy for them to understand. We need to make sure that our data set is consistent, so it follows a specific format. It has common standardization that will ensure that the data is useful even if you kind of merge it with another data set and such. And this will kind of also lead to the accuracy of the model. Now, if you have clean data, this will actually obviously improve the accuracy of the models that rely on it, because once you build a model, what is our kind of end goal? Our end goal is to have a good, high performing model with the least errors. And this is why data cleaning is very important. This stage is very important because it actually really affects the accuracy of the models. So we've cleaned our data, we've collected our data, we've cleaned our data. Now we go to the kind of analysis part or the data preparation. So there are some terms here that we use. We have the univariate analysis. So basically, this is where you actually explore or kind of analyze variables one by one, just like its name. Bivariate is you explore relationships between variables. So these are just terms that you need to keep in mind as you work with data, data science, and such, because in this step you kind of will hear them a lot. We have the missing values, which, as we said, for example, you could get a spreadsheet, an Excel sheet, rows and columns and such. However, some fields are missing. So it could either be, like a mistake from the person who was entering the data, or it could actually be missing for whatever reason. Outliers. So this is something that is out of range and doesn't really make sense or does not belong to the data set. So for example, let's say you have the age feature or age field. So if you see like the age is from, you have numbers from 1 to, let's say, 80. And then one of the fields says 10,000. You know that this is an outlier because obviously we don't have an age of someone, a person who is 10,000 years old. So this is why we need to treat an outlier. And we also have feature engineering, which is one of the ways that we use in the data preparation or analysis. And this is basically transforming variables and creating new, better variables from raw features. Now, in this kind of step, we have great tools for this to be used, and one of those is structured query language or SQL. It's very good to have a kind of knowledge or base understanding of SQL to be able to work and understand everything that you're working with in the data preparation or analysis part. We have Python. Python is actually one of the most, I would say, beginner friendly, easy to use, obviously, languages. And because it has amazing libraries that will help you build your data science knowledge. So it has libraries like NumPy, Pandas, Matplotlib, scikit-learn, Skippy, and many, many, many more. And each one is actually used for something. So you want libraries for computational, computational algorithms, for machine learning algorithms, for visualizations. We can use Matplotlib and scikit-learn for processing and such. So you have many huge libraries that will help you, analyze the data for you. And you obviously have R as well, or R Studio, which is basically another programming language that you can use. And it has also other libraries as well, as we can see. So these are important. And for me, I would recommend, to kind of, follow the tool that you feel, more comfortable, explore them at your own pace. But I would highly recommend Python if you are beginning and you don't know where to begin. Python is my recommendation. And in fact, if you don't know how to get into Python, or you want to get started into learning Python and you're scared, I have added for you a learning module that is actually on our Microsoft Learn platform. That will actually help you, start your learning journey into kind of introducing the basic principles of Python and kind of getting into that whole world of Python. So stay tuned for the end. I will add the link for you. So next, you have exploratory analysis. And as I mentioned, exploratory analysis or exploratory data analytics, EDA, is one of the most important stages that we as data scientists, love to do. Because you as a data scientist, you need to have a strong technical mind. So you need to kind of look at the data that you have after cleaning it and after processing it and such, and kind of start making your own conclusions from it. So by making your own conclusions, I mean summarizing the main characteristics, for example, making assumptions, discovering hidden patterns and such. So this is a step that we actually use and is very important in the steps. And also in exploratory analysis, we use summary statistics. So exploratory analysis, once you kind of go through the process, it can show us some summary statistics such as like the mean, the median, the minimum, the maximum, the quartiles, like first quartile, second quartile, and third quartile. And also we can do that to visualize histograms and box plots. Here is an example. So for example, we have a data set for temperature and such, or Walmart store sales forecasting data, for example. So for the temperature, you can see here the numbers that you have. It gave us the mean, the minimum, the maximum, the standard deviation and such. And also we have visualization of a histogram and a box plot. Feature engineering. This is where obviously we create new features from existing raw features and such. This is one of the ways that we use in the analysis kind of process. And some if you have extremely, for example, skewed data, this means You have like outliers that you need to treat, and imputation is basically filling in missing data. So this is kind of one of the terms that you also need to know and keep in mind once you go through that process. We have missing values. So as I mentioned before, sometimes you typically as data scientists, when you have a big data set of, let's say, like 10,000 records, it is normal to have some missing values or unknown values. So, and these missing values can lead to incorrect estimations or biased models. So it's very important to kind of know how to deal with that. So therefore there are some ways that you can deal with missing values. We can either omit them or remove them and use the available data, or we can impute by replacing them by the mean or the medium or the mode value of the existing data, and such. So these are some ways of, just to give you an idea of that, of how we can treat those. We have outliers, as I said. For outliers, you can use box plots or histograms and scatter plots to kind of detect where the outliers are. And obviously, those outliers are so out of the range, numbers that don't belong or data points that don't belong in the data set. So this is also something that we need to treat. Then, after we kind of treated that, we will go and build our predictive data modeling. So the end goal of us in a data science project or data science lifecycle is to predict, right? So to do that, we want to predict, for example, predict future consumer behaviors and take action accordingly. So this is where you will actually, use machine learning algorithms to predict the kind of data modeling that we have. Some examples include like recommendation systems, customer purchase histories to determine, for example, how to put on the price for products, the stock market, and even display future products. Next, we have the machine learning. So machine learning, as I said, is a very integral part of data science. And it's very important to know that we have various machine learning algorithms that we use, for kind of basically everything. You need to kind of be able, as a data scientist or as a beginner, to differentiate between the different algorithms that we have. So it really depends on the task that you're looking for. So if you have a task like prediction, if you have classification problem, if you have a task like clustering and such, it really depends. Under each kind of task you have falls several types of algorithms. And I will kind of summarize it to you in a way in a bit. So machine learning is the study of algorithms that improve their performance at some task with example data or past experience. So it is a foundation to many machine learning algorithms, as it lies obviously in statistics and such. And so here, for example, machine learning systems are actually made up of like three main parts, and those are the model, the parameters, and the learners. Keep this in mind because I want to show you the way, how you can kind of know how to classify these machine learning algorithms. So they can basically be classified into three categories. We have supervised learning, unsupervised, and reinforcement learning. So supervised is when you have labeled data. So for example, let's say you want to detect the fraudulent transactions in a list of, for example, credit card transactions. This is where it is supervised. So you want to kind of predict a value. Unsupervised is unlabeled data, as we said. So it kind of, you're asking the model to process the data from which you can then draw conclusions. So for example, based on spend data, you want to segment the customers. Reinforcement learning is basically where, the model learns by trial and error. So this is actually the closest thing to how we as humans learn. And for example, you have the personalized recommendations on streaming platforms like YouTube and Netflix and such. So, as I mentioned, we have a lot of algorithms, of machine learning algorithms, that we can depend on for our data science project and in our data science lifecycle. However, I kind of here summarize it here for you in a way to kind of give you an idea of what to use and when to use. So, just to kind of explain what we have here, you have machine learning, and under machine learning, you have three types of learning that we talked about: supervised, unsupervised, and reinforcement. And under each kind of category, you have the types of problems that are related to that. So if it's a classification problem, you can use the following kind of algorithms. If it's a regression problem, you can use these algorithms. If it's clustering, these. And if it's decision making algorithm problem, you can use these algorithms. So this is kind of just to summarize a way on when you get stuck on when to use what. There's no specific way, but this is a format that you can follow. In fact, this is a machine learning algorithm cheat sheet that I got for you from our Microsoft Azure platform. And the link for this cheat sheet, if you're looking for it, is aka.ms/ml cheat sheet. So, so based on what you want to do, if you want to extract information from text, you can use text analytics. So, and based on that, you have the different algorithms that help you understand exactly what you want to do. If you want to predict values, then means this is a regression problem. And under regression falls different types of algorithms. So you can use linear regression for example, fast training and building a linear model. It depends on your goal. And for example, the last one we want to give is, for example, let's say you want to predict between two categories. You will use a two-class classification. So basically, this cheat sheet that you have right in front of you kind of helps you choose the best machine learning algorithm for your predictive analytics solution. And basically, this kind of gives you an overview of when to use what and how to use it and such. So when you want to kind of build a model and you don't know what to use, this is just a summary of all the amazing different algorithms we have at machine learning. Obviously, since we have an hour to do this session, we're not able to go through each one. However, this is just a kind of summary of everything. And some application examples include, for example, let's look at association analysis. You have basket analysis, meaning if you want to find the probability that somebody who buys X also buys Y, you need to know how this person, if that person buys apples, will also buy oranges, for example. You have supervised learning, for example, you have classification, like spam filters, such as, in the email. So Google Gmail actually uses classification or spam filters to, filter the emails that are spam and immediately, put them in the spam kind of field. You have regression, for example, you want to predict the pricing, or you have recommendation systems. And in unsupervised learning, it is, as we said, we gave examples on that. Now, we talked about all about machine learning models and such. So you applied the model to your data set, to your data problem and such. Then you kind of have to know there's like a training and testing split procedure, which is used to estimate the performance of the algorithms when they are used to make predictions on the data that is not used to train the model. So this is a step that actually is very important to help us estimate the performance of the algorithm that we applied. So why do we say this? Why is it called train test? Because we need some data to train our model on and some data to test our model on to see if it's actually working or not working. And data scientists, most of them have agreed or noticed that the 80 to 20 ratio, so 80 being 80% of the data is used for training and 20% of the data is used for testing, or 70% of the data is used for training, 30% is used for testing, is the most widely used ratio and gives the best result for our algorithm. So obviously, this is a very important step because you have a huge data set. You want to take a huge portion of that to train the model, do all that kind of machine learning algorithm processing, and then it will give you the result based on the testing data that you have in order to see the performance and evaluate, that model. So this is where we have to split our data into training and testing. And in supervised learning, it's important to know that, we feed the training data to the algorithm and we feed the testing data to the actual model. So machine learning algorithms, anything that has to do with the algorithms and the model building and such, we will use the training data for that. And the testing data will be used for the actual performance of the model. And obviously, since there's two types of algorithms for supervised learning that we use to classify something or predict a value, we have classification models or regression models. And very quickly, the types of supervised learning, because these are two of the most common types that you will obviously hear about a lot, is classification and regression. Classification is when you want to classify something into a class or category. So, for example, classifying if an email is spam or not. Or regression is when you want to predict a numerical value. So for predicting, the price of your house, or predicting, the sale price or something. So after you kind of did that, all that, you split your data, you're done, you built your model. Now you want to kind of select, build, and test the model that you have. This is where the analytical approach actually is becomes tested, and this is where you kind of ask some questions. For example, what are the data types that I have? Is there a time index? What models are used for other for other problems to be solved? So with a few candidate models selected based on the problem that you have, this is where you actually start obviously building the model, testing it, and actually tuning it. And this is where you actually, in this step, you actually, after you build your model, you will configure it based on, the results and the performance it gives you, and you'll start fine tuning it to get better accuracy. Our goal by the end of all of that is to have to give the best results. To give the best results, we want a high accuracy and a very low error rate. And this is the goal. So we need to kind of test and check our model by the end of it, and it will, show us if we have a high accuracy and a low error, then that means we have a good result. Lastly, after we selected our model, we built it and we tuned it, we make sure we want to deploy our model and get it into production to help us lead to the decision or the action that we want. So some examples of what model deployment can look like, for example, is you want to, by the end of all that analysis, you decide that you want to raise your price, you decide that you want to open a new branch, you want to launch a promotion and such. So this is obviously where model deployment comes into play. It helps you take the next step towards what the next decision is. Lastly, and the final step is to monitor and validate the results to see, remember that what the first step was is we defined our objective, and you look at the end and you see if these two are correlated to each other and they make sense, and you reach the goal that you want, and if the outcomes are as expected. So for example, in order to do that, you can do some summary reports, some dashboards, some charts and such. And this is where you use data visualization. With data visualization, we convert raw data to visual objects and figures. And obviously, we use visualizations to help us summarize all our analysis that we have done previously. So there are many ways to, obviously, we have different types of visualizations, and to make your life a bit easier, uh, I will help you kind of show you a summary of how to choose the best chart for your data. So depending on what your goal is, here I have summarized for you, depending on the goal that you want, you can use what type of data visualization. So for example, let's look at the compare sector. If you want to compare categories or show composition, you can use a bar chart or a pie chart, for example, or a schema. If you want to show the change over time, you have the time, over the years and such, and you want to show the change, you can use a timeline, which shows the distinct events in time. Um, if you want to organize, something like rankings or such, or processes, you can use a list, you can use a flowchart, a table, and such. So this is kind of a way where it helps you kind of summarize the different visualizations you have, and it's very important, as I said, to know what type of visualization to use and when to use it. Now we've talked all about that. You may ask me, Hadeel, okay, that's a lot of information, valuable information, but how do I actually get started? Here are some tips and tricks for you, from someone who is a data scientist myself, someone who's like an expert in the field, on how you can get started in the data science field. The first tip I would give you is to kind of first begin by familiarizing yourself with the most foundational and most important concepts in data science. So we are lucky to live in a world where we have the internet, we have online resources, free resources at our own pace, valuable information, valuable content, and rich content. So we have Microsoft Learn. And Microsoft Learn is one of the amazing platforms that I myself, as Hadeel, as a cloud advocate, and as a data scientist myself, still use to this day, in order to kind of, look at all the learning paths that we have from different topics and such, and learn at my own pace. It has free learning resources from every single tech topic you can think of. So if you go on Microsoft Learn and search, for example, data science for beginners, you will find plenty of resources that will help you start your data science learning journey. And we have a GitHub repo. So as I mentioned, I'm going to show you now in a bit, the GitHub repo. So we have a GitHub repo that is for data science for beginners. This is an actually deep dive. I would highly recommend for everyone to kind of check this one out. This is not to be missed out on because it shows you a lot of things that we have not covered today. So, for example, let's say you want to know about data ethics or data privacy, or for example, you want to know more about probability and statistics. You want to know about the different visualizations and kind of understand why we use histograms and such. This is where we have our GitHub repo. So it's very important to kind of you know you know build that framework of knowledge that you have. Next, kind of have a basic understanding of probability and statistics. So obviously, since you will be building machine learning models in your data science journey and such, very important to not have, let's say, not be an expert in the field in math, but it's very important to at least know the basic concepts, take a basic simple course, probability and statistics. And actually we have this section of probability and statistics is actually summarized in our GitHub repo, which I will share with you in a bit. The third tip is if you want to get into the data science field, learn a coding language. So familiarize yourself with any of the tools or languages that we have. Is it Python? Is it R? Is it Julia? Is it Java? You choose. My best recommendation is Python. And for that, since it's very beginner friendly, it's very easy to use, it's, learning at your own pace. I will add for you a link in the next slide and show you an introductory course to get into Python. Next, we have, I would highly recommend to you after you've kind of did all the deep dive learning and all your foundation concepts, start actually finding data sets online, by web scraping or by going through Kaggle or Microsoft Azure data sets. Kind of look for data sets and start practicing by applying those concepts into actual real life. So the more practice, the better. So let's say you're looking into kind of looking for transportation data. Go find for transportation data and actually work on a project where you apply the machine learning algorithms that you've learned, where you apply all the data science lifecycle steps that you've learned and such, where you go through the data cleaning process, data analytics process, and the model building and evaluation and such. Lastly, I would highly recommend for you to kind of connect yourself with the data science community around you in order to share like-minded, ideas with, with people in the community and kind of exchange, ideas with them as well, and also to get to know about more opportunities in this field. Now, if you don't know where you can find a data science community, your best bet is to join us on our Microsoft Reactor Middle East and Africa group on Meetup, where we kind of have a community of data science experts, not only data science and experts in the field, regional cloud advocates, we have some guests, we have some amazing top speakers who kind of always share this amazing knowledge and rich content on data science and on other tech topics as well. And obviously, since we live in a, we are like running on a kind of hybrid or an online digital world now. We have plenty of opportunities that you can find. You can search in your local area where you can find a data science community in order to always stay up to date with the latest technologies, tools, and trends with people around you. So that being said, let me share with you the links that I have showed you before. So the data science beginners first link is this GitHub repo. And this GitHub repo is an actual curriculum, which is 10-week, 20-lesson curriculum about data science. And it has, the fun thing about this is it has a lot of quizzes, instructions to complete lessons, solutions, and it's very fun. It's a very fun way to learn data science. So I would highly recommend for you to check it out, because, for example, let's see here. Look at the different topics that we have covered in that repo. So you have the grouping of the lesson, you have the linked lesson, and it shows you the objectives. So let's say you want to know get into an introduction to statistics and probability. You can just kind of go into the link and find a video for that lesson or a PDF of that lesson, or if you want to work with Python and such. So it's very, very, very useful, and I would highly recommend for you to check out this repo because this is kind of where most of our content today was generated from this repo. However, obviously, due to the time, I would highly recommend for you to check out all the other sections that we have not covered today and such. So highly check out this repo, and there is an actual PDF for this one. So if we check here together, it is absolutely amazing, has valuable, rich content that will help you get started on your data science journey, where to get data, digital transformation, and so many more topics that you could literally think of with challenges and quizzes and such. So I would highly recommend this link. The next link is an introduction to Python for data science. So if you want to get into data science, it's very important to know a coding language, and I would highly recommend for you to get into and to use this learning, path for Python in order to learn at your own pace and such. This is very important because it is, it helps you understand and get into the world of Python without, if you don't have any coding experience and such. This is actually very beginner friendly, and it helps you kind of at your own pace, begin. So once we look here, it shows you like an introduction, how to set up your environment and all that, how to test it, how to write comments and such, and even how to try it yourself. So I love this Microsoft Learn document because it is very useful and kind of takes it to the right steps for that. So check this one out as well and complete it. I would highly recommend for you to complete it because it's very useful. That being said, we are done for today. Thank you so much to everyone for attending. I hope you had a great time. I sure did. And for that, stay tuned for the next session. We are not done. So the next session for the continuation for our data science for beginners journey will be on the 16th of November, next Wednesday at 3 p.m. GST, which is a live stream event as well. So highly recommend for you to kind of continue your learning journey with me. We'll be exploring more concepts, applications, and so much more. That being said, I am done, and thank you all so much. Please make sure to join us on our Microsoft Reactor Middle East and Africa group. And that being said, I will see you next time. Bye-bye.